Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime Series 24, Episode 53. Coming up on SpaceTime, determining the age of Earth's continental crust, more funding to build the world's biggest radio telescope, and an exciting new interstellar mission on the drawing boards. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims Earth's continental crust first emerged some 3.7 billion years ago. The findings, presented at the European Geological Union's General Assembly, show that the planet's light continental crust formed within the first 900 million years of the Earth's existence. The continental crust is the layer of granitic, sedimentary and metamorphic rocks which forms the continents in the areas of shallow seabed close to their shores, known as the continental shelves. It's less dense than the oceanic crust material and therefore floats on top of it. Unlike previous research, which is based on strontium isotopes and marine carbonates, which are usually either scarce or altered in rock more than 3 billion years old, the new study by scientists from the University of Bergen looked at the mineral barite, which forms from sulfates in ocean water mixing with barium from hydrothermal vents, and thus holds an unchanging record of ocean chemistry going back through time. The authors calculated the ratio of strontium isotopes in 6 different deposits of barite from 3 different continents, ranging in age from 3.2 to 3.5 billion years. This allowed them to determine when weathered continental rock percolated into the ocean and was incorporated into barite. The authors determined that the weathering started about 3.7 billion years ago. That's around 500 million years earlier than previously thought. The findings provide a new understanding of Earth's early ocean chemistry, as well as the onset of plate tectonics. And they even help understanding the evolution of the biosphere, because once processes like plate tectonics help establish the continents, processes like erosion can begin to weather crucial minerals and nutrients into the ocean. This is SpaceTime. Still to come, more funding for the world's biggest radio telescope, and an exciting new interstellar mission on the drawing boards. All that and much more still to come on SpaceTime. The Australian government has provided another $387 million in support funding for the Square Kilometre Array project to build what will be the world's largest radio telescope. As well as construction of the telescope arrays themselves, the package will also provide over $64 million in funding towards building one of the world's biggest and fastest supercomputers in Perth, needed to process the huge amounts of data which will be gathered by the observatory. The Square Kilometre Array project will use 2 networks consisting of hundreds of dishes and thousands of antennas distributed over hundreds of kilometres of the Australian outback and the South African Karoo. These will be split up into the SKA low-frequency phased arrays, which will be dipole antennas covering the 50 to 350 MHz frequency range and grouped in 100-metre diameter stations, each containing around 90 elements. The SKA mid-frequency array will include several thousand 12-metre diameter dishes covering the 350 MHz to 14 GHz frequency range. And the SKA survey array will use a compact array of 12 15-metre diameter parabolic medium frequency dishes, each equipped with a multi-beam phased array feed covering the 350 MHz to 4 GHz range. Its size and wide range of operating frequencies will make the square kilometre array at least 50 times more sensitive than any other radio telescope in the world. The Australian facility will be based at the CSIRO's Murchison Radio Astronomy Observatory in Western Australia, where it already has 2 operational main instruments. The Square Kilometre Array Pathfinder, or ASCAP, which uses 36 identical 12-metre parabolic dishes working together as a single instrument for high-sensitive surveys. And the Murchison Wide Field Array, which comprises 8300 MHz low-frequency cross-correlating signal dipoles mounted on 128 phase tiles comprising 16 dipoles each. A third separate instrument at Murchison is EDGES, the experiment to detect the global epoch of reionization signature antenna and low-noise amplifier radio telescope. It's designed to detect the redshifted 21-centimetre hydrogen line from the cosmic dawn, an epoch of reionization. Meanwhile, South Africa has its own precursor facility known as Meerkat, an array of 64 13.5-metre dishes covering the 580 MHz to 14 GHz frequency range. There's also the 7-dish Cat-7 engineering and science testbed instrument. The new Perth supercomputer will be complemented by a second unit in South Africa, the pair working to process the unprecedented amounts of data expected to be produced by the observatory. Some 60 petabytes of data is expected to be stored and distributed worldwide to the science community every year. That's enough to fill more than 500,000 top-end laptops. Construction of the project will begin early next year and take at least 10 years to complete. The project's partners include Australia, the Netherlands, Canada, China, France, Germany, India, Italy, Japan, Korea, Portugal, South Africa, Spain, Sweden, Switzerland and the UK. To find out more, Andrew Dunkley is speaking with astronomer Professor Fred Watson.
The Australian government's chipping in a mere $387 million.
That's real money. I mean, it's. I have to say that my colleagues, people I work with and amongst in the Department of Industry, Science, Energy and Resources, who put together the budget considerations and things, they were working flat out on this for the past few weeks. And certainly last week, they were getting it all tidied up. So what this signifies is the Australian government's ongoing support for the Square Kilometre Array project, which is 2 telescopes, an array of 131,072 antennas, which look like Christmas trees in Australia. That's the low-frequency array. The mid-frequency array is going to be in South Africa, where they have something like 60 dishes, which look at, the slightly higher frequency range. So a 2-pronged attack on the universe to build the world's biggest telescope, and this signals Australia's ongoing support for it. Of course, governments always have to put the positive spin on things like jobs and growth. Those are the mantras of governments all over the world. And indeed, there's big numbers involved there too. There are something like 350 new jobs being created during the construction period, the 10-year construction period. And then over the 50-year life of the project, because this is going to outlast you and me, Andrew.
Yes.
There'll be 230 ongoing positions. This is serious stuff. These are big numbers for the jobs that this gigantic project will build. And just to mention as well that, 2 things. One is that it's not just Australia in this. There are, I think, 16 nations are now signed up for it, 16 member countries all over the world. Actually, I might just list them because it's quite an interesting bunch. Australia, Canada, China, France, Germany, India, Italy, Japan, Korea, the Netherlands, Portugal, South Africa, Spain, Sweden, Switzerland, and the United Kingdom are in there.
Wow.
You might notice one country that isn't in there is the United States, because their interests in radio astronomy don't really align with what the SKA member countries are doing. So it's not taking your bat and going home or anything. It's just a natural thing about the scientific endeavours of these countries. But to anybody who's listening to us in one of those listed countries, well done. Your country is part and parcel of the SKA community. And what I was going to say is that investment that the Australian government has put in, it means that what you're doing is you're stimulating foreign income flows into Australia because of that. And certainly in the first 30 years of operations, they estimate 1.8 billion in foreign income will come into Australia. So very important stuff. And one final thing to mention is is that there is a chunk of that budget, 64.4 million, in establishing a specialist supercomputing centre, which will be in Perth, Western Australia, to do all the thing about the SKA is it generates 10 times the current, or it will generate 10 times the current internet traffic on the whole of the internet, and they'll do that 10 times over. So you need these enormous computing centres to do that. It's very exciting stuff. I'm delighted we could get a chance to talk about it. And well done, Australia. That's that's me waving my flag for the country that is closest to my heart.
I suppose we should, just for the sake of it, refresh people's memories as to what the SKA's role is going to be. What are we trying to achieve with it?
So it's remarkable. Its remit is the entire history of the universe, basically, because the kinds of things it will be looking at are the dark ages, that time between the Big Bang and the first star switching on, when the universe had a lot of cold hydrogen in it, which the SKA will be able to not only detect, but to map it out, to see where it lay and how that formed the universe's growth. And then things like the origin of magnetic fields in the universe. That's one of the key targets of the SKA. One that I am very interested in and very keen on is that SKA will detect very large numbers of pulsars. These are neutron stars, spinning neutron stars, that essentially let us test gravity at very extreme levels. Neutron stars and black holes are the most gravitationally strong objects that we can see. And so what you're really interested in is looking at these objects in detail to see whether relativity still works at these high gravitational intensity levels, because relativity is our best theory of stuff in the universe, but we know it's got holes in it. We know it doesn't completely work. So this is one of the things that, in fact, I had in mind when about 2 years ago, I went before a committee, a high-level political committee, which was ratifying the treaty that the square kilometre array, the international treaty that it's going to be built under. And I promised them Nobel Prizes, which might have been, I said they had my personal guarantee that this would generate Nobel Prizes, and that actually appeared in Hansard. But so it was not
on record.
Not entirely a throwaway comment. Of course, at my age, I can promise anything, Andrew, but it's not a throwaway comment, because I believe that if the SKA reveals insights into the absolute fabric of reality that underpins all of relativity and quantum theory and everything, and it may well do, that will certainly generate Nobel Prizes. So all of the above, plus just finally, coming right up to date, the SKA can detect an airport radar at 50 light years, so who knows what we might pick up going on in our neighbourhood in the universe in terms of intelligent species.
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. Still to come, an exciting new interstellar mission on the drawing boards, and a successful high-altitude test flight for SpaceX's Starship. All that and more still to come on Space Time. NASA is looking at a major new mission to explore interstellar space beyond the solar system by actually going there, rather than just looking from near-Earth space. Current plans would see the mission launch in the early 2030s, taking about 15 years to reach the heliosphere boundary and lasting well over 50 years in total. When the twin 1970s vintage Voyagers 1 and 2 spacecraft crossed the boundary of the solar system and entered interstellar space back in 2012 and 2018 respectively, scientists around the world celebrated the stunning achievement. The two probes had entered a new part of the galaxy, 3 times further away from the Sun than Pluto and 120 times further away from the Sun than what the Earth is. This boundary, known as the heliopause, marks the end of the Sun's heliosphere, the bubble encompassing our solar system that's filled with a solar wind. Voyagers discovered the edge of the bubble, but it's left scientists with lots of questions about how the Sun interacts with the local interstellar medium. The problem is, Voyager's instruments can provide only limited data. They were designed for a grand tour of the solar system, studying the gas giants. And that's meant there are crucial gaps in science's understanding of the region known as interstellar space. NASA and partners are now planning for a new spacecraft, currently simply called the Interstellar Probe, to travel much deeper into interstellar space, 1,000 times further out from the Sun than the Earth. The mission would tell astronomers more about how the heliosphere formed and how it's evolved as the Sun and Solar System undertake their 225,000 Earth-year journey around the galaxy. The Interstellar Probe Heliospherics lead Elena Provonikova from the Johns Hopkins Applied Physics Lab in Maryland says the mission will explore the unknown local interstellar space, where humanity has never reached before. For the first time, humans will be able to take a picture of the heliosphere from outside to see what our solar system really looks like. Mission planning is already well underway, with scientists and engineers now looking at the types of science packages the spacecraft will need. Astronomers hope to discover how the Sun's plasma interacts with interstellar gas to create the heliosphere, what lies beyond the heliosphere, and what the heliosphere actually looks like. Provonikova says the mission will image the heliosphere using energetic neutral atoms, and it will try to observe extragalactic background light from the early epoch of the galaxy's formation, something that simply can't be seen from Earth. Scientists hope to learn how the Sun interacts with a local galaxy. That, in turn, could offer clues about how other stars in the galaxy interact with their interstellar neighbourhoods. The heliosphere is important because it helps shield the solar system from high-energy galactic cosmic rays. The Sun and Solar System are currently in what's called the local interstellar cloud. But recent research suggests that we may be moving towards the edge of the cloud, after which we'll enter a new region of interstellar space, a region we know nothing about. That change could cause the heliosphere to either expand or contract, and that could affect the amount of galactic cosmic rays which penetrate the heliopause, in the process changing background radiation levels on Earth. The Interstellar Probe mission is now in the final year of a 4-year pragmatic concept study looking at the types of science that could be accomplished within the mission. At the end of the year, the team will deliver its report to NASA. It'll outline potential science, example instrument payloads, and example spacecraft and trajectory designs for the mission. Provonikova says the idea is to lay out a menu of what could be done through this mission. This is SpaceTime. Still to come, a successful high-altitude test flight for SpaceX Starship. And later in the science report, a new study warns that Antarctic ice sheet melting will lift sea levels higher than previously thought. All that and much more still to come on SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
SpaceX has performed the successful high-altitude test flight of its latest Starship prototype in Texas.
It was almost 5 weeks ago. We launched Starship 11 on a test flight from the adjacent Pad B. Today's flight is from Pad A. Our demonstration objective again is with the last 4 flights. Slowly climb to 10-kilometer altitude, which will take about 4 minutes, turning off engines on the way up as we burn off propellant mass. Once we reach 10 kilometers altitude, we will begin the horizontal descent back to the landing zone adjacent to the launch pad. If all goes well, we'll light 3 engines to flip the stage back to vertical and eventually land on a single engine. This flight includes multiple upgrades and improvements. To address the findings from the rapid, unplanned disassembly we experienced on the last flight, this vehicle also incorporates changes that get us closer to the orbital configuration planned for flight later. We continue to count down for Starship 15 flight. Pellet load is complete in the liquid oxygen system on the Starship. Methane fuel load is also complete on the Starship.
As with earlier tests, the SN15 test article lit up 3 Raptor engines to launch vertically and then climb to an altitude of 10 kilometers, shutting off first one and then a second engine during the ascent.
T plus 30 seconds, Starship 15 is airborne. The 3 Raptor engines powering our way to 10 kilometers altitude in today's test flight. Just past 1 minute into flight, we're through 2 kilometers altitude. All 3 Raptor engines continuing to burn. Next major event, about 1 minute, is we will turn off the first of the 3 Raptor engines. Raptor engines continuing to perform, and we've got shutdown on engine 3 on time. We continue to ascend. We have just passed the 8-kilometer point in flight. Everything continues to look good on Starship 15. Coming up on 3.5 minutes into flight, we're approaching the 10-kilometer altitude. We'll begin to hover here. We've had engine number 2 shut down on time. We'll now be moving into the hover with 1 engine, and then in a little bit we will begin the flip over to horizontal position and begin our descent.
Once at the correct altitude, SN-15 performed a series of maneuvers, including a propellant transition to the internal header tanks, which hold the landing propellant, allowing a controlled aerodynamic horizontal descent actively guided by the independent movement of 2 forward and 2 aft flaps on the vehicle. All 4 flaps are actuated by an onboard flight computer to control Starship's attitude during the flight, before the test article reignited its Raptor engines and reoriented itself vertically again for landing on a pad adjacent to the launch pad.
Just past T plus 4 minutes into flight. We're in the horizontal descent phase now. We're passing 6 kilometers. Now, a reminder, phase that's coming up as we get ready for landing, we will light 3 Raptor engines, flip the vehicle from horizontal to vertical. If things look good, we will shut down 1 Raptor engine and then possibly a second one and land on a single engine in the landing zone. Raptor continuing to descend. We're coming up on 3 kilometers altitude. And we have ignition. Starship heading back to the landing zone. And Starbase Flight Control has confirmed we are down. The Starship has landed. We're going through the safing sequence in the flight computer right now. We do have a small fire at the base of the vehicle. Not unusual with the methane fuel that we're carrying as we continue to work on the test vehicle design. Water going on the pad from the water cannons. But again, Starship 15, powered by 3 Raptor engines, we have successfully launched it from our facility in South Texas, landed after a routine flight where we shut engines down on the way to 10 kilometers, executed the horizontal unpowered descent, the engines lighting up as we came down for a landing at a nice slow velocity onto the concrete landing pad. Also like to remember, this is the 60th anniversary of the first American in space, astronaut Alan Shepard and his Mercury capsule, and SpaceX has landed Starship successfully on this date.
The SN-15 test article features numerous major structural, avionics, software and engine improvements over earlier versions which ended up in spectacular explosions. These included a new enhanced avionics suite, updated propellant architecture in the aft skirt, and a new Raptor engine design and configuration. In-space refueling, combined with a controlled aerodynamic descent using flaps and a vertical landing capability, are all crucial aspects Starship will need in order to fulfill its mission as a fully reusable interplanetary and colonial transport system, operating to the Moon, Mars and beyond, places where runways don't exist, and then returning to the Earth again. The final operational product will be a 120-ton, 50-metre tall spacecraft, 9 metres in diameter, and constructed out of gleaming stainless steel. Its operations will be powered by 6 liquid methane and oxygen-fueled Raptor rocket engines, 3 configured for atmospheric operations and 3 for the vacuum of space. Starship is designed to lift 150 tons of people and cargo into Earth orbit, and 100 tons on more distant missions from the Earth to the Moon or to other planets across the solar system. It will be launched into orbit by a 68-metre-long, 230-ton booster stage powered by 37 Raptor engines. That's about to begin tests in Texas shortly. Starship's first mission will be to provide shuttle services for NASA between the Gateway Space Station and the lunar surface. SpaceX plans on eventually using the Starship launch system to replace the company's existing Dragon spacecraft and its Falcon 9 and Falcon Heavy launch systems. This is SpaceTime.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study warns that the Antarctic ice sheet's melting will lift sea levels higher than previously thought. The new calculations by scientists at Harvard University and reported in the journal Science Advances show that the rise due to climate change will be some 30% above previous forecasts. What's different is that the new calculations include a water expulsion mechanism, which occurs when the solid bedrock under the West Antarctic ice sheet rebounds upwards as the ice melts and the total weight of the ice sheet decreases. See, the bedrock sits below sea level. So when it lifts up, it pushes water from the surrounding area into the ocean, thereby adding to global sea level rise. The new predictions show that in the case of a total collapse of the ice sheet, global sea level rise estimates will be amplified by an additional metre within 1,000 years. A new report warns that at least 2 Chinese government hacking groups have exploited vulnerabilities in VPN security devices to infiltrate several American and European aerospace and defence industry, as well as government and financial sector computer networks. Security consultant Mandian says the cyber spying operation used malware to try and hijack user and administrator identities and enter systems between October 2020 and March this year. One of the cyber hacking groups was identified as UNC 2630, which operates on behalf of the Chinese government and may have ties to another Chinese state-sponsored hacking group known as APT5. The US State Department has approved a $2 billion deal, which will see the Australian Army purchase 4 additional CH-47F Chinook helicopters and 160 M1A1 tank structures to build M1A2 SEP version 3 Abrams battle tanks and M1-150 assault breacher vehicles. The ADF currently operates just 10 Chinooks and 59 Abrams tanks. Are you sick of recharging your smartwatch at night? Well, scientists have developed a new small flexible device that can convert heat emitted by the human body into electrical power. The research, published in the journal Cell Reports Physical Science, shows that the device could power an LED light in real time when worn on a wristband. The findings suggest that body temperature could one day power wearable electronics such as fitness trackers. The device, known as a thermoelectric generator, uses temperature gradients to produce power using the difference between the warmer body temperature and the relatively cooler ambient environment. More updates from Apple. Coverage increases for both Telstra Mobile and the NBN's fibre to the node, and a new report showing that the past decade has seen the most rapid change in technology in history. With the details on those stories and more, we're joined by technology expert Alex Zaharov-Reutt from ITWire.com.
Yeah, well, we're now up to iOS 14.5.1, so there's updates again for your iPhones, iPads, Apple Watch and Macs. There's no update for the Apple TV. Now, these are patching yet more security vulnerabilities that have been actively exploited, and it's the white hat hackers who are looking for these. They obviously want to get paydays from Apple and other companies as bug bounties. But, if they weren't finding these things, then these would be used as zero-day attacks against people, and they could be installing malware or doing other nasty things. So it's a shame that there's so many updates, but it's better to have updates than no updates. And so if you've got any of these Apple devices, please update. And if you haven't updated in the past, do it again. And if you have an old iPhone that's running iOS 12, there's been security updates for that too. So even if you have an older iPhone, it's worth checking.
NBN's adding more homes to its fibre rollout. Tell me about it.
Yes, well, they just announced that there are 900,000 more homes that will be eligible for a fibre upgrade. Now, the catch is that they have to order a 250 megabit plan. But of course, people are always wanting faster and faster plans. The cheapest 250 megabit plan in Australia is $89 from a company called Mate, but also companies like Aussie Broadband have been very competitive. The big catch at the moment is that these plans have been 6-month special deals, and then with Mate, for example, the price goes to $109 Australian per month. And what some of the ISPs have been noticing is that people will stick with the cheap provider on their special deal for 6 months, and then they'll turn to somebody else. But at least we're seeing these 250 megabit and faster plans becoming more common in Australia. The NBN has announced, a couple of million homes will be upgraded to fibre directly to their home. It'll cost $3.5 billion. It should be complete by 2023, after which I suspect more homes will be rolled out. Some of the newest homes announced will be switched on starting from November 2021. So this is another decade of broadband upgrades for Australia.
Not just the landlines. Telstra has announced mobile coverage improvements for regional areas.
Yes, they're going to spend $200 million over the next 4 years to basically install more mobile towers and provide more coverage where it isn't currently available. I noticed that in Australia and also when I've been in the US that you can be in certain regional areas, you drive from one town to the next and there's no coverage. I mean, what happens if you have an accident or, you need to get in touch with somebody? You just have to wait for the next person to come along, or you have to have a satellite phone. Telstra is spending $200 million. So as you travel around Australia, you should find far fewer areas of where there's no service than you currently do now over the years to come.
The Australian Digital Consumer Study by Telsite's been released. Tell me about it.
Sure. Well, they're talking about a decade of rapid change. They say that in the last decade, from 2010 to 2020, we witnessed the most rapid technology change in Australia's history. For example, we now have 21.6 million smartphones in use, which is up from just 4.4 million in 2010. And people are spending $14.4 billion on digital goods and services in 2020, which is up from only $2.2 billion in 2010. So there's been a huge amount of growth. But of course, now with COVID-19, that growth is accelerating even faster. And there's a whole bunch of interesting stats that they've discovered. The number of internet-connected devices in Australia has grown almost sixfold, from less than 35 million in 2010 to 193 million last year, which is only going to grow further. When it comes to the NBN and mobile broadband, we've had huge improvements in internet connectivity. 30% of Australians now have a 100 megabit or faster plan compared to the 78% that were on ADSL plans with speeds of less than 15 megabits sort of this time in 10 years ago. And also improved broadband speeds means that the average usage of broadband has increased by 793%. This is from 28 gigabytes of monthly usage in 2010 to 250 gigabytes in 2020. So everything has just gone crazy. But now, whether it's online shopping that's grown from 32.9 billion last year, nearly tripling from the 11.5 billion in 2010, or interest in video services. Video subscription has grown more than 40-fold between 2014 and 2020. It reaches now more than 16 million services. 3 in 5 Aussies, that's 62% of Aussie households, were using at least one subscription video on demand service at the end of 2020, which compared to, a decade ago, I don't even think Netflix
Think of all those
existed.
old empty Blockbuster stores.
That's right. Well, it's all Netflix, Disney Plus, Hulu, Stan, all the rest now. But part of the growth in digital has also seen that 1 in 3 Australians are very concerned about fake news. Half now always check the validity of news sources that they see online, because we all know about how untrustworthy, some news services can be. Cybersecurity concerns are also growing because of the rapid adoption of connected technologies and the shift to digital lifestyles. We have nearly 30% of Australians who've experienced some form of cybercrime just last year alone. That includes things like account hacks, phishing attempts, ransomware, identity theft, and even cyberbullying. And then when it comes to things like smart speakers, and back to the happy side of things, 2.8 million households had a smart speaker at the end of 2020, and the estimates are that this could grow by more than 50% in the next few years. So definitely the decade of 2020 to 2030 is just going to continue exponentially growing.
That's Alex Zaharov-Reut from ITY.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel. And on Facebook, just go to facebook.com/spacetime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.